Hey guys, so today we're going to see a hard problem number 642 in LeetCode, design search autocomplete system. One of my subscribers had asked for this problem to be explained. So here it is today. So let's quickly read the description. So basically this is bare minimum version of the Google auto search functionality. There are some disturbances here, so sorry for that. So let's quickly read the description. So design a search autocomplete system for a search engine. Users may input a sentence, at least one word, and end with a special character, hash. For each character they type except hash, you need to return the top 3 historical hot sentences that have prefix the same as the part of the sentence already typed. Here are the specific rules. The hot degree of a sentence is defined as the number of times the user typed exactly same sentence before. The return top 3 hot sentences should be sorted by hot degree. The first is the hottest one. If several sentences have the same degree of hot, you need to use ASCII code order. Smaller one appears first. Basically, they're saying that if two sentences have the same frequency of occurrences, so basically you have to return the lexicographical ordering first. And if less than 3 hot sentences exist, then you should just return as many as you can. And when the input is a special character, it means the sentence ends, and in this case you need to return an empty list because it means that we'll be seeing this string for the first time, so we have to basically return it in our historical data and return it. So they're talking about this constructor function. As you can see on the right hand side, it takes in an array of strings, sentences, and an array of ends which denote the frequencies of each of these sentences. Okay. And they're talking about the second method, list of string input char c. So if you see, c is the next character typed by the user. The character will only be lowercase letters a to z, blank space or a special character hash. Also, the previously typed sentence should be recorded in your system. The output will be the top 3 historical hot sentences that are prefixed the same as the part of sentence already typed. So let's look at the examples. Okay, so autocomplete system, you have some 4 words given, right? An array of strings is given. I love you, island, Iron Man, and I love LeetCode with their corresponding frequencies 5, 3, 2, 2. So I love you occurs 5 times, island occurs 3 times, Iron Man occurs 2 times, and I love LeetCode occurs 2 times. Now the user is typing in I. Now if you see, all the sentences in our historical data start with I, right? So but we need to return only the top 3 hot sentences. So out of these 4 sentences, 5 is the highest frequency sentence. So you can just say I love you, you can return. And then the second will be island because it has 3 as the frequency. And for 2 times you have a tie, Iron Man and I love Rico. But in the explanation you see that space has ASCII code 32, whereas R has ASCII code 114. So which means I love LeetCode should precede Iron Man. So that's why in the output, if you see, the top 3 returned are I love you, island, I love LeetCode, because space has a lower value compared to R. Okay, and let's look at example, operation, this particular operation. So if you see, user has typed in space. So in our historical data you see anything. So first of all, user typed in I, and then now he has typed in a space. So the current string is I and space. So in the historical data, if you see, the 2 sentences which have I and space are I love you and I love LeetCode. So you can only return 2. And as per one of the rules, if less than 3 hot sentences are present, then you have to return whatever is present. So you are just returning only 2. So I love you and I love LeetCode are returned. Now user is typing in A. Actually in our historical data we see that we do not have any sentence which starts with I, space and A. So which means we have to return an empty list. Right? So an empty list is returned. And now user has typed in hash, which signals end of the search. So when end of search occurs, then you have to return an empty list, because that is rule number 4, right? It says like when an input is a special character, it means the sentence ends, and in this case you should need to return an empty list. and basically you have to record that value as well, right? So let's consider I have a set of words here. Whatever values that they've given, right, all start with I. So let's say I have, something which starts with A, and apple, and then X, right, and then something with B, let's say B, ball, and so basket, okay, and then C, you have something called cat, and then you can say, site, something like that. So in a dictionary, as soon as you give some word, right, so you are given some word, like let's say, bat. In this case, intuitively what you will do is, given a, intuitively how will you design the system? Given a word bat, you will try to find whether, historical data, anything that starts with B, right, and then you will basically search in this space. So anything that starts with B is ball and basket. Out of this you will see whether bat is present, bat is not present, and in that case you have to return an empty string, empty list basically. So the same idea can be adopted here. So what you can do is you can have an array of hash maps, and each array, each index in the array is nothing but, the starting character. So for example, if you have apple, then it will go in A-th hash map, right, and if you have something called bat, it will go in B-th hash map, okay. And basically what you can have is you can record the frequencies as well. So apple comma 5, so you see a word like say airplane, okay, and you see that airplane is starting with A, so which means it has to go in A-th hash map, let's say axis 7, and so we're saying airplane for the first time. Let's say in this case you'll go ahead and say put it in A-th hash map and say that it has occurred once, okay. So we need to have an array of hash maps, okay. So let's quickly go ahead and have an array of hash maps. Hash map, I'm going to say string and integer because we're going to have sentences and the corresponding frequencies. This is going to be an array, so I'm just going to call it as array, and the number of English alphabets is 26, right? At the maximum we can just have 26, and we're indexing these array with the starting characters, and they're saying that the input is going to be lower A to lower Z, so which means you're just going to have smaller A to Z, which is 26 letters, right? So this is going to be new hash map of 26, right? So we're going to have 26, the array's size is going to be 26. We're going to have 26 different hash maps. Now let's go ahead and initialize the individual hash maps. Index equal to 0, index is less than 26, index plus plus, and then what we're going to do is array of index is equal to new hash map string comma integer, yeah, and so we've initialized the hash maps. Let's go ahead and quickly record the sentences and the corresponding frequencies and the appropriate hash maps, right? So index is equal to 0 and index is less than sentences dot length, yeah, index plus plus array of, we have to basically get the first character and then put it, basically get the sentence and put it in the appropriate hash map tagged with the first character. So which means sentences of index dot char at of 0 minus A, right, because this has to be an integer, and so we'll put in this hash map, we will put what is our key. It is sentences of index, okay, and what is our value? Times of index, okay, in this hash map. So for our historical data, if you consider, I love you, right? So we will put it in, it's, it starts with I, so you'll get the sentences of index, which is I love you, dot caret of 0, which is I, minus a, it will give you the integer counterpart, and then in that hash map you're putting the key as sentences of index, and times of index will be the value. Now we've initialized it. Okay, so let's come to the second method. Now this returns a list of strings, so let's initialize that. Okay, list of string, I'm going to call it as result, and I'm going to initialize it as new array list. Okay, we're basically going to return this, so let's return result. Okay, so now there are two cases. Now C can be hash, which means user has finished his search, right, which means the current string has to be added. So we need to have a variable which keeps track of what is the current string, right? So let's have string current string equal to empty. Yeah, and so if C equal to hash, this means current string has some characters. Okay, let's take this example, right? So which means when you encounter some hash, right, so user has completed a search. In this case you have to basically put in the current sentence into our data structure. Basically you have to record the current sentence, right? So what you're going to do is array control has gone somewhere up, so okay, so in this case what you have to do is we'll just put it in a corresponding hash map. So corresponding hash map, so our current string is the current string that was recorded. So let me copy this. So array of current string dot char at of 0 minus a small array. This is going to give us the corresponding map value. So here you have to put what is going to be our key value. Our key value is nothing but the current string, right? So we have recorded the current string. What is going to be our value? If at all if you have seen this earlier, so then we will have some value. So in that case current string dot char at of 0 minus a, right, dot get, if at all if it is already present in our data structure, then we'll get its frequency and increment it by 1, otherwise we'll initialize it with a value of 0 as its frequency. Okay, and so we have to also reset current string as empty, because this means our search is going to be new, the user is going to have a new search. Yeah, and let's have else, where we will handle the other conditions. So when search ends you have to return the empty list, right? So in this case we'll just say current string is equal to this one, and so the control will come out and return the result, which is an empty array list. Now we have to account for the cases where user is typing in something which is other than the hash character. So in that case what you have to do is, suppose user is typing in our example, user is first typing in I, which means you have to add it to our current string, right? So let's add it to our current string plus equal to C. Okay, now what you have to do is we have to basically identify all the words in our data structure which map with our current string. So now user has given input as I, so what we did, we went ahead and we saw all the words in our dictionary or in our data structure which matched with I, and then what we did, we took the top 3. Basically we sorted them based on the decreasing order, and if at all if there was a tie, then we took the lexicographically least order among them and returned the top 3. So basically I have to do all those. Now our hash map is in the form of string comma frequency. So basically we need to have another list and sort it to get the words in the higher frequency manner. So I'm just going to have another one class. I'm going to call it as word freak. Okay, and this is going to have string sentence, and then it is going to have int frequency. Okay, and the constructor is going to have freak, and I'm going to say string s comma int f. Okay, and sentence is equal to s, and frequency is going to be f. Okay, now let's have a list. So basically why are we having this? To just sort them. Okay, basically collect all those which match with our current string, and then sort this list to get the required top 3 hot sentences. So let's have a list of word freak. I'm going to call it as list. So this is going to be new array list. Okay, so let's take whatever values are matching with our input string. So basically we'll go to that particular hash map. So in this case our current string, let's say in this case user has typed in I, right? So we have to go to ith hash map, right? So which means array of current string dot caret of 0, right, minus a. Now we have reached the appropriate hash map. From this we have to collect all the key strings, right? So which means we will be collecting all I love you, I love Iron Man, and I love LeetCode. Okay, we have collected all. So now what you have to do, we have to check whether our input string is matching with them. For I, it was matching with everything. For I and space, it was matching with 2, right? So basically we have to add all those matching entries to our list. So for that we need to basically check whether, in the case of I space, what we did, we checked whether that I space is a prefix of any of the words that we had in our data structure. So for that what you're going to do is, if key dot index of, if this current string is present in this key, right, then obviously its index is going to be 0, right? In that case we can directly go ahead and add new word freak. Okay, and here what is going to be your key value? It's going to be, the sentence is going to be your key. And what about the value, right? We'll get it from our hash map, corresponding hash map, because this is something which is already present in the hash map. So we're just going to retrieve the value of this corresponding key. Okay, we're going to retrieve the frequency of this particular key. So let's take it. So current string, right? Basically if this is matching with the current string, which means array of current string dot caret 0 minus a, okay, and dot get of key. Okay, we have added it to our list. So let's see whether we have closed all braces properly. So we are adding key comma the frequency. The frequency is nothing but the corresponding, get the corresponding hash map. Yeah, get the corresponding hash map, which is string dot caret of 0 minus a dot get of this particular key. This is going to give us this one. Now we have got a list of words comma their frequencies. Now we have to sort it. So collections dot sort what we're going to do is we're going to sort this list. Now what are we going to do? So the comparator is going to be a comma b, and basically we have to see. So if you see, I introduced a new class word freak. It has sentence and frequency, right? So we have to basically handle the case where if their frequencies are both equal. So if a dot frequency if this is equal to b dot frequency, right? If this is the case, we need to return the lexicographically shortest string, right? So what you're going to do is a dot sentence dot compare to, it is the inbuilt compare to function, b dot sentence. Okay, if not, we'll just use the decreasing order of frequency, b dot frequency minus a dot frequency. Okay, so this is going to be our comparator. Now we have sorted our list. Now we have to take the top 3, and if top 3 is not present, whatever is present, whatever minimal is present, we have to take it. So for that we need to do index equal to 0, index is less than, math dot min of 3. If list size is greater than 3, then we're going to just take 3. Otherwise, whatever is present in the list, we're just going to take whatever is present in the list. Okay, index plus plus. So we'll add result is going to be our output, right? Result dot add list dot excuse me guys, get of index dot sentence. We just need the sentences. Okay, so let's quickly walk through an example. So for example, let's say user has typed in I. Okay, so when user has typed in I, we'll add it to our current string. So our current string is just I, and then we'll go to ith hash map and take all the key set, which means all the values, and we'll basically check if I as a prefix of these values. Yes, it's a prefix of, so we'll basically add all these 4 to our list, right? Key comma array of current string dot caret of 0, which is ith index dot get of key. So which means key is I love you. In the case of I love you's value 5 will be returned, and so we're basically adding I love you in 5, I learn in 3, and Iron Man in 2, and I love LeetCode642. And then we'll sort it based on their frequency. If their frequencies are equal, then we compare the lexicographical order. Otherwise, we'll sort them based on their decreasing order frequency. And now we'll take the top 3. And so in the top 3 would be I love you, island, and I love LeetCode. Yeah, and let's say user has typed in I in space, the current string will be, so current string is, it's not hash, so which means current string will come here. Initially we saw I, so I in space, so we'll go to ith hash map and retrieve all values, out of which only I love you and I love LeetCode will match with this. So we'll just go ahead and add those 2 values, and we'll sort them, so 5 and 2, and we'll return, so the minimum is going to be just the list dot size, which is going to be 2, so we'll return those 2 sentences. In the case of I space A, we will not be adding anything because nothing matches with that. In that case, we will be just returning an empty result. And in the case of I space A and hash, when user types in hash, then we'll go ahead and update the current string, and basically we'll just get the current value if it is already present and increment it by 1. Otherwise, we'll initialize the value with 0. Basically initializing the frequency with 0 if it is not present, if you're saying it for the first time. And then we'll reinitialize the current string to empty, so that when the user starts a fresh search, then he'll be able to do the search, get the top 3 hot sentences, and basically record that sentence as well. Okay, I hope it was clear. So let's quickly go ahead and run this code. A dot frequency. Okay, there is a spelling mistake. Where is it? A dot frequency. Yeah, it's accepted. Let's go ahead and submit it. Yeah, and it's a successful submission, guys. So I hope it was clear. As you can see, you're basically having, you know um, 26 hash maps, and basically adding all those sentences in them, and basically doing a search on the historical data that is present with us, right? I hope it was clear. So like this video, comment on it, and if you want any other extra information on it, please let me know. And if you want me to explain certain solutions, or you want me to look at certain problems, do let me know in the comments. I'll try to accommodate that in my upcoming videos. So thank you so much, guys, for all your support. Bye.